You know, it's actually really funny how we're conditioned to look at our bodies, kind of like a car
Oh,
dashboard.
yeah.
Like the
Ah,
check engine light comes on, right? And maybe it's a headache or chronic fatigue or heartburn that just will not quit. And our very first instinct is usually just to find a way to turn the light off.
we just want the quick fix.
Exactly. We want the quick fix so we can get back on the road. So we take a pill to numb the pain, or we drink coffee to fight the fatigue. We chew an antacid to put out the fire in our chest, and then we just keep driving.
Right, you just ignore the actual engine.
Yeah, but what if the problem isn't the light itself? What if, like, smashing the light bulb on the dashboard is actually the worst possible thing you could do for the engine?
Because the light isn't a malfunction.
Yeah.
I mean, the light is this highly evolved communication system, right?
Right.
It is your physiology functioning perfectly to warn you that something much deeper is chemically or structurally out of balance.
Yeah.
And when we constantly silence the messenger, we just allow the actual cellular damage to spread completely unchecked.
We're mistaking the alarm for the actual fire.
Exactly.
Well, welcome to another deep dive. Today we are unpacking a really dense rapid-fire Q&A session from human biologist Gary Brecka. It's from his Ultimate Human platform.
And if you've listened to any of his material, you know it is a wild ride.
Oh, it's intense. I mean, it covers everything from this seemingly mundane stuff like acid reflux and egg allergies, all the way to chronic, incredibly complex issues. Things like mold toxicity and Lyme disease.
But our goal here isn't just to give you a list of biological trivia or you just read a table of contents to you.
No, not at all. We really want to connect the dots across all these different answers and extract the overarching biological philosophy that he's presenting.
And that philosophy actually provides a really powerful analytical framework for us.
Yeah.
Because the fascinating theme connecting all of these completely disparate medical questions is this central tension between root cause resolution and just symptom management.
Right.
As we go through this material, you're going to notice conventional medical wisdom being flipped completely on its head.
Over and over again.
The argument being made isn't just that we fail to treat the root cause. It's that we're often treating the exact opposite of what the body actually needs. Like
Yeah.
we're inadvertently making the foundational problem worse while we temporarily mask the symptom.
Okay, let's unpack this. Because I want to ask you, the listener, have you ever been frustrated by a lingering symptom that just won't go away, no matter how many over-the-counter remedies you throw at it?
We all have, right?
Yeah. And if you have, today's deep dive is going to offer you a totally new lens on how your body's systems interact. So we are going to start with a paradigm shift that honestly completely blew my mind.
This one is wild.
It really is. And it takes place right in your stomach. It's the massive misconception surrounding acid reflux.
Acid reflux, or GERD, is incredibly common.
Yeah.
And the standard response is almost universal, right? It's acid blockers.
Yeah, like Tums or whatever.
Right? Proton pump inhibitors, H2 antagonists, you name it. And the assumption is pretty straightforward. Your chest is burning, acid is splashing up into your esophagus, therefore you must be overproducing acid.
It seems so logical. Like, we eat a heavy fatty meal or a rich tomato sauce, we feel the burn, and we immediately reach for the alkaline tablets to neutralize it.
But the argument here is that this is fundamentally backwards. The claim is that acid reflux is generally caused by having too little stomach acid, not too much.
Which on its face sounds completely counterintuitive. I mean, if my chest is literally burning from acid, how can the root cause be a lack of acid?
I know it sounds crazy, but understand the mechanism. We have to look at the cardiac sphincter.
Okay.
This is the muscular valve separating your esophagus from your stomach. Its entire physiological purpose is to stay tightly closed during digestion so that churning vat of hydrochloric acid doesn't splash upward.
Because it would incinerate the delicate esophageal tissue.
Yes,
Right?
that tissue lacks the thick, protective mucosal lining that the stomach has, but this sphincter, it doesn't just open and close randomly. It is chemically triggered.
Right. And it's highly sensitive to the pH environment of the stomach.
Right. Precisely. The cardiac sphincter is triggered to open in response to alkalinity. And it's triggered to clamp shut in response to extreme acidity.
Wait, hold on. Let's make sure we have this straight, because this is where the conventional logic completely falls apart for me.
Let's hear it.
It's basically like a high-tech security door on a bank vault that only locks when the alarm is deafeningly loud.
That's a great way to put it.
So if the alarm is blaring, meaning the stomach acid is incredibly strong, sitting at a really highly acidic pH of like 1.5 or 2, the door clamps shut. It's locked tight. Nothing is getting through.
Right. The mechanism is working perfectly.
But if the alarm is weak, meaning your stomach acid is too diluted, sitting closer to a pH of like 4 or 5, the security system doesn't trigger. The door just stays lax.
That is exactly what is happening biochemically.
Mm-hmm.
And because the door stays lax, that weaker diluted stomach acid is able to freely splash up into the esophagus.
Oh, wow.
Now, a pH of 4 is weak for the stomach, but it is still plenty acidic enough to chemically burn the unprotected tissue of your esophagus.
So you feel that burn and you immediately think, oh, I'm producing too much acid.
Exactly. But the mechanical root cause is that your acid wasn't concentrated enough to trigger the sphincter to lock the door in the first place.
So when you take an antacid or proton pump inhibitor like Tums or omeprazole, you are temporarily neutralizing whatever acid splashed up, right, which makes the pain stop in the moment.
Right, it's a relief.
But long term, you are actively making the stomach even more alkaline. You're essentially guaranteeing that the security door will never receive the chemical signal to lock properly.
Yep. You are setting yourself up for a permanent structural failure of that valve. You are managing the symptom while actively exacerbating the root cause.
That is mind-blowing.
It really changes how you look at digestion. And this is why the actionable insight derived from this framework goes in the exact opposite direction. Instead of blocking acid, the suggestion is to actively increase its concentration.
By taking a supplement, right?
Yeah, they recommend supplementing with betaine hydrochloride. They specifically mention Thorne as a reliable brand for this. The objective is to introduce an exogenous acid to aggressively drop the pH level in the stomach.
So restoring the chemical trigger so the cardiac sphincter gets the signal to shut tightly.
Precisely.
But there's a massive caveat here that we really have to talk about. You can't just throw away your PPIs cold turkey if you've been on them for years, right? I mean, the rebound effect is brutal.
Oh, it's terrible. The rebound effect is actually a really fascinating piece of compensatory biology. When you take a proton pump inhibitor, you are chemically forcing the acid-producing parietal cells in your stomach to shut down.
Right, you're turning off the tap.
But your body wants to digest food. So in response to this suppression, it starts pumping out massive amounts of a hormone called gastrin. It's essentially screaming at the parietal cells to work harder.
Oh, no.
Yeah, and the parietal cells actually physically enlarge, they hypertrophy, trying to overcome the medication.
So if you just stop taking the medication abruptly...
You have these massive, hyperactive parietal cells being stimulated by high levels of gastrin, and suddenly the chemical dam is removed. You get a massive tsunami of acid overproduction.
Ouch. That sounds incredibly painful.
It is. And this is why you have to slowly, meticulously titrate off of them. You have to gradually wean yourself down to give those cells time to shrink back to normal size while you slowly introduce the betaine HCl to rebalance the natural environment.
It's a really delicate rebalancing act. You're essentially retraining the chemical environment to function the way it actually evolved to function.
Exactly.
But this concept of a delicate internal environment, it doesn't stop at the stomach. If the stomach is the security door and the initial chemical breakdown vat, the lower gut, like the intestines and the colon, that is the true command center of your immune system and your nutrient absorption.
Oh, absolutely.
And that barrier is equally fragile.
And arguably under even more assault. The material brings up a very common medical procedure that acts as an absolute wrecking ball to this command center.
The colonoscopy.
Yes, the colonoscopy. Now, to be completely transparent, the platform explicitly states this is not meant to replace the advice of a gastrointestinal specialist, right?
Of course. Colonoscopies are vital diagnostic tools for detecting polyps and cancer. No one is saying don't get one.
Exactly. But the concern raised isn't about the scope itself. It's about the collateral damage of the chemical bowel flush required beforehand.
Right. It's basically the nuclear option for the microbiome. The prep flushes everything out.
Everything.
And it doesn't just clear out waste, it violently strips the intestinal walls of all the beneficial bacteria, the mucus layer, the entire thriving ecosystem. You are essentially strip mining a rainforest.
That's a perfect analogy. And repopulating that rainforest isn't as simple as eating a little cup of commercial yogurt. The strategy laid out here is incredibly specific, focusing on a two-part symbiotic approach: probiotics and prebiotics.
Let's differentiate the two because I feel like people often conflate them.
Yeah, all the time. Probiotics are the actual living microorganisms, the beneficial bacteria strains that you were trying to parachute back into the gut.
Right, the actual bug.
Yep. They mentioned specific high-quality formulations like Dr. Stephen Gundry's BioComplete 3 or their own proprietary blends. But a critical factor here is the delivery mechanism.
Because of the stomach acid we were just talking about, right?
Exactly. If a probiotic isn't acid protected, those live bacteria are going to be instantly incinerated by the stomach acid. They have to survive transit to the alkaline environment of the lower intestine before the capsule breaks down.
Okay, so let's say you manage to successfully parachute the new bacteria into the gut, but this is where most protocols fail, right? Just dropping them there isn't enough.
Nope.
You have to actually feed them. If you drop a workforce into a barren, strip mine landscape with zero rations, they just die and fail to colonize.
Which brings us to prebiotics. Probiotics are the bugs. Prebiotics are the specific types of fuel those bugs evolved to eat.
And what are the undisputed champions of the prebiotic world according to this biological framework?
Fermented vegetables.
Yeah.
Kimchi, sauerkraut, pickled vegetables, and kefir.
Why fermented vegetables specifically, though? Like, what makes them the ultimate gut superfood?
It really comes down to a beautiful piece of biological chemistry involving insoluble fiber.
Mm-hmm.
Your body on its own lacks the enzymes to digest insoluble fiber.
Right, we just can't break it down.
Right, so it passes through your stomach and small intestine completely intact.
Mm-hmm.
But when it reaches the colon, your microbiome, those beneficial bacteria we just introduced, they recognize it. They feast on it. They undergo a fermentation process.
Oh.
And the byproduct of that bacterial fermentation is the synthesis of free fatty acids, most notably a short-chain fatty acid called butyrate.
Butyrate, that is the magic word here. This is where it goes from just being, good for digestion to being a systemic cellular mechanism.
Exactly, because butyrate isn't just waste. It is the primary energy source for the cells lining your colon.
Wow.
And furthermore, butyrate is a powerful epigenetic modulator. It literally signals the immune system to downregulate inflammatory cytokines.
Because it turns off inflammation.
Yeah, and it actually tightens the tight junctions between the cells of your intestinal wall, preventing undigested food particles and pathogens from leaking into your bloodstream.
So you feed the bacteria fiber, and they essentially manufacture highly targeted anti-inflammatory gut-sealing medicine for you right on site.
Right there in the colon.
That is incredible. And this idea of the gut needing constant repair leads right into a very specific case study that was brought up in the Q&A regarding gastroparesis.
Right, gastroparesis.
Yeah.
Which literally translates to stomach paralysis.
Oh, wow.
Yeah, the vagus nerve, which controls the migrating motor complex.
Which is what exactly?
It's the sweeping contractions that move food through the digestive tract.
Ah, okay.
Well, that nerve is damaged or misfiring, so the stomach's motility is severely delayed. The individual asking the question mentioned being dependent on long-term antibiotics due to this condition.
Because when food just sits stagnant in a paralyzed stomach, pathogenic bacteria overgrow.
Exactly. But as we just learned, long-term antibiotics are constantly carpet bombing the lower gut microbiome.
Right. It's a catastrophic, vicious cycle. So how do you break a cycle like that?
The protocol laid out here is an aggressive heal, seal, and repair methodology. First, they target the mechanical misfiring. They suggest methylfolate.
Why methylfolate?
Because the nervous system requires optimal methylation to synthesize neurotransmitters, like acetylcholine, which is the primary chemical messenger the vagus nerve uses to tell the stomach muscles to contract.
So you're repairing the electrical signaling, basically.
Exactly. But then you have to address the structural damage from the chronic antibiotics. And they bring in a heavy hitter for this colostrum.
Right. Colostrum is the primal first milk produced by mammals immediately after giving birth.
It's not just nutrition, though. It is a complex biological data transfer.
Right. It's packed with immunoglobulins, specifically IgA and lactoferrin.
Right. The evolutionary purpose of colostrum is to program the newborn's naive immune system and rapidly seal their highly permeable, brand-new intestinal lining.
And the argument here is that these same growth factors and immune proteins can aggressively repair a damaged, leaky adult gut.
Yes. They recommend brands like Omra, but uniquely, they strongly advocate for sourcing raw colostrum directly from a farmer's market.
Oh, interesting. Why raw?
Because the pasteurization process, which uses very high heat, permanently denatures many of those fragile, heat-sensitive immune proteins. It renders them biologically inert.
Ah, that makes sense. And as a final step in this gut protocol, they introduced the concept of binders, specifically mentioning Toxiprevent lower GI.
Binders are crucial here.
I really want to pause on binders because they play a massive role in the next part of our discussion. Binders aren't absorbed by the body right.
Correct.
They are substances with very specific molecular structures and electrical charges that travel through the digestive tract, acting like basically molecular sponges.
Right. They electromagnetically attract and trap inflammatory compounds or endotoxins so they can be excreted rather than reabsorbed through that damaged intestinal wall.
So it's basically a cleanup crew. You have the colostrum repairing the walls, the methylfolate fixing the electrical signaling, the prebiotics feeding the workforce, and the binders hauling away all the debris.
It really is a masterclass in treating the body as a holistic ecosystem.
It totally is. But, we just spent all this time talking about how crucial it is to seal the gut wall and maintain that barrier. But why does that wall matter so much?
Because of what's outside it.
Exactly.
Yeah.
Because the moment that internal barrier is compromised, the things we breathe and touch, the external environment, they gain direct access to our bloodstream.
And that brings us to, honestly, the most intense part of this material. What happens when invisible environmental toxins mount a full-scale invasion?
Right. Let's talk about mold toxicity.
The stance taken on mold and mycotoxin poisoning is arguably the most uncompromising advice in the entire platform.
Oh, absolutely.
They state an absolute non-negotiable rule. If a functional medicine blood test shows you are suffering from mold toxicity, the very first thing you must do is physically remove yourself from the environment.
Right.
You cannot stay in the house or the office that is exposing you. You will never heal in the place that is actively making you sick.
Okay, I have to push back on this a little bit because practically speaking, telling someone to just up and move or abandon their home is often financially impossible for most people.
Oh yeah, it's a huge burden.
So why is it an absolute rule? Like, can't you just use really high-end air purifiers and aggressively detox while you remediate the house?
I get that, but it really comes down to the saturation kinetics of the liver.
Okay, explain that.
So mycotoxins, which are the toxic chemical byproducts produced by molds like Stachybotrys or Aspergillus, they are lipophilic.
Meaning they like fat.
Exactly. They dissolve easily in fat, which means they easily cross cellular membranes and accumulate in your neurological tissue and organs. Now, your liver has detoxification pathways, phase 1 and phase 2, designed to neutralize toxins. But they have a maximum processing capacity.
Oh, I see. So if you stay in the environment.
If you are sleeping in a room with toxic mold behind the drywall, you are inhaling millions of spores every single night. You are introducing mycotoxins into your bloodstream at a rate that vastly exceeds your liver's capacity to process them.
So trying to detoxify your body while remaining in the environment is basically like trying to bail water out of a sinking boat with a teaspoon while someone else is drilling holes in the hull with a power drill.
Exactly. You are mathematically guaranteed to lose. The systemic accumulation will continue to drive chronic inflammation and neurological symptoms regardless of what supplements you take.
Wow. So you literally cannot out-supplement continuous toxic exposure.
Yep.
But okay, once you do manage to get into a clean environment, the detoxification protocol they outline is incredibly aggressive. This isn't just a 3-day juice cleanse, right?
No, this is heavy-duty physiological intervention.
Yeah, it starts with the air you breathe. They recommend purifiers that filter down to 0.3 microns, but the really critical element is the use of ozone.
Ozone is a recurrent, heavily utilized tool in this framework.
So what exactly is ozone doing here?
Well, ozone is O3, right? A molecule composed of 3 oxygen atoms, whereas the stable oxygen we normally breathe is O2. That extra oxygen atom makes ozone a highly unstable, highly reactive oxidant. When ozone gas encounters a mold spore, it induces lipid peroxidation.
Which means?
It literally oxidizes and shreds the lipid membrane of the spore, destroying it on contact.
Oh, wow. So it just blows it up.
Yeah. Running an ozone generator in an empty room, and it must be empty because it is incredibly caustic to the lungs, it actively neutralizes the airborne threat.
Okay, so that sterilizes the external environment, but what about the mycotoxins that are already deeply embedded in your fat cells and your brain tissue?
That's where they return to those binders we talked about earlier.
Right. Activated charcoal zeolite, which is a highly porous volcanic mineral, and a specific binder from Dr. Daryl Geoffrey called Kick Your Acid.
The biological necessity for these binders involves something called enterohepatic circulation.
Okay, break that down for us.
When your liver successfully processes a mycotoxin, it dumps it into your bile. That bile is then secreted into your small intestine to help digest fats.
Makes sense.
But here is the design flaw. Your body recycles bile. If there is no binder waiting in the gut to intercept that mycotoxin, it gets reabsorbed right back through the intestinal wall, back into the bloodstream, and sent right back to the liver.
Oh, it's just a continuous exhausting loop.
Exactly. Now, zeolite and charcoal have a strong negative microscopic charge. Mycotoxins often carry a positive charge, so the binder electromagnetically locks onto the toxin in the gut, breaking the recycling loop, and allows it to be safely excreted.
Okay, here's where it gets really interesting, though, and honestly a bit intimidating. They don't just rely on passive binders, they advocate for deep systemic flushing using active ozone therapies inside the body.
Right.
They list intravenous ozone EBUO, which is extracorporeal blood oxygenation, and ozonation 10-pass ozone, and something called a HO-CAT machine.
Ah, the HO-CAT. That stands for hypothermic ozone carbonic acid transdermal therapy.
Okay, walk us through what that actually looks like.
Mechanically, it looks like a high-tech individual steam sauna cabinet. You sit inside it with your head poking out the top so you can breathe regular room air. Inside the chamber, the temperature rises, inducing a deep sweat and opening your pores. But then the machine pumps in carbonic acid and highly concentrated pure ozone gas.
Wait, hold on. I need to stop you right there. You're saying I should sit in a sauna and pump ozone, which we just established is a highly reactive, destructive oxidant that shreds cell membranes directly into my open pores.
Yep, that's exactly what I'm saying.
But isn't oxidative stress exactly what we are usually trying to avoid? I mean, we take vitamin C and we eat blueberries specifically to stop oxidation. How does the body differentiate between quote-unquote good oxidation from this machine and bad cellular oxidation that causes aging and disease?
That is the exact right question to ask. And the answer lies in a biological concept called hormesis.
Hormesis, okay.
Hormesis is the phenomenon where a low-dose exposure to a stressor induces a highly beneficial adaptive response. Think of exercise, right? You're literally tearing muscle fibers, creating oxidative stress, but the body overcompensates by building them back stronger.
Okay, so the ozone is acting as a stressor.
It's exactly. When that transdermal ozone enters your lymphatic system and bloodstream, it causes a brief calculated spike in oxidative stress. This mild threat acts as a massive signaling molecule.
Okay.
It activates a genetic pathway in your cells called the NRF2 pathway.
NRF2.
Yes, and when NRF2 is triggered, it commands your DNA to radically upregulate the production of your body's own endogenous antioxidants, primarily glutathione superoxide dismutase and catalase.
Oh, I get it. So you aren't using the ozone to manually hunt down every single mycotoxin. You're using the ozone to basically kickstart the body's internal antioxidant manufacturing plant into high gear.
Precisely. It is a transdermal delivery system that bypasses the digestive tract entirely, using that unstable O3 molecule to force the cells to aggressively detoxify themselves from the inside out.
Wow.
It is a profound, albeit intense, physiological hack.
That completely changes how I view it. It's not poison, it's a physiological alarm clock.
Exactly.
And this intense strategic approach to fighting invisible enemies carries perfectly into their perspective on Lyme disease.
Oh, Lyme is notoriously complex.
It really is. It's caused by the Borrelia burgdorferi bacteria, usually from a tick bite. But the framework here describes chronic Lyme not just as a stubborn bacterial infection, but as a condition that fundamentally exhausts and hijacks the entire operating system of the immune system.
Right, because Borrelia is a stealth pathogen. It's a spirochete, a corkscrew-shaped bacterium that literally drills deep into joint tissue, nervous tissue, and the heart, hiding from immune cells.
Oh, it's awful.
And it also forms dense biofilms to protect itself from antibiotics. Dealing with it requires a massive amount of immunological energy.
What's really fascinating here is how this material unpacks the collateral damage of that energy drain. They make a crucial insight, right? When people with chronic Lyme are suddenly suffering from chronic fatigue, neurological issues, or sudden viral outbreaks, they aren't usually catching new viruses from the environment.
Mother out.
They are being attacked by dormant viruses they have carried inside them for decades.
Right. Almost all of us are carrying a reservoir of dormant viruses. If you had mononucleosis as a teenager, the Epstein-Barr virus is still residing quietly in your B cells.
Wait, really?
Oh, yeah. If you had chickenpox, the varicella zoster virus is dormant in your nerve roots. Under normal circumstances, your immune system dedicates a small fraction of its surveillance resources to just keeping those viruses suppressed in a latent state.
Let's use a tech analogy, because I think it captures the mechanics perfectly.
I love a tech analogy.
Imagine your immune system is your computer's CPU. It's central processing power. Normally, keeping Epstein-Barr suppressed is like running a background app. It takes up maybe 2% of your CPU. You don't even notice it.
Right, it just runs quietly.
But an active Borrelia infection is like launching massive, highly demanding 3D rendering software. It spikes your CPU usage to 100%. All your system's RAM, all its processing power is entirely consumed by fighting the Lyme.
And because 100% of the resources are diverted to the primary threat, The firewall maintaining those background apps drops completely.
Exactly. The system glitches, and suddenly those background viruses realize the surveillance is completely gone.
So Epstein-Barr reactivates flooding your system with viral replication. Paracella wakes up and you develop shingles.
You now have a catastrophic secondary viral outbreak on top of the bacterial Lyme infection. The CPU is completely fried.
It's a multi-front biological war.
Mm.
And this mechanism explains exactly why the recommended protocol for Lyme isn't just take more antibiotics.
Right. Prolonged
Prolonged antibiotics might slowly chip away at the Borrelia, but they're concurrently destroying the gut microbiome, which, as we established, houses 70% of your immune system's processing power.
You are crippling your own CPU while trying to fight the virus.
Exactly.
So the protocol completely shifts focus. It is entirely about upgrading the hardware and supporting the immune system so it can fight the war on its own terms.
Right. They recommend high-dose intravenous vitamin C, and not just as a simple antioxidant.
Oh, really?
Yeah, when vitamin C is administered intravenously at massive doses, it actually acts as a pro-oxidant in the extracellular space.
Wait, pro-oxidant? Like it causes oxidation?
Yes, it generates hydrogen peroxide that selectively kills bacterial cells while leaving healthy human cells completely intact.
That is so cool.
They also emphasize evaluating your genetic pathways, specifically looking for single nucleotide polymorphisms, or SNPs, in the glutathione detoxification pathways, like the GSTM1 gene.
Right, we mentioned glutathione earlier. It's the master antioxidant.
Exactly. Glutathione is the body's master antioxidant and primary detoxifier synthesized primarily in the liver. If you have a genetic variation that drastically reduces your ability to manufacture or recycle glutathione, your body's ability to clear the cellular debris from the battlefield is severely compromised.
The dead bacteria, the inflammatory cytokines.
Right. You're fighting the war, but you can't clear the dead bodies from the streets, so the inflammation just spirals out of control.
So testing these genetic pathways isn't just trivia, right? It allows you to bypass the broken machinery and supplement exactly what your unique biology is failing to produce.
Which brings everything back to this central idea, providing the body with the exact precise raw materials it needs to execute its own brilliant programming.
Which perfectly bridges us into the metabolic architecture of the body. Because once you've removed the environmental toxins, once you've stopped the multi-front immune war, the dust finally settles.
But you are left with damaged tissue, depleted hormones, and exhausted organs.
The body has to rebuild. But to build, you need bricks mortar and a clear set of blueprints.
And this brings us to some of the most controversial territory in the entire Q&A, fundamentally redefining how we view the raw materials of metabolism.
Let's start with the mortar-right cholesterol. For the last 50 years, the prevailing medical narrative has absolutely demonized cholesterol.
Oh yeah, it's public enemy number one.
It's the ultimate villain of the American diet. The sticky substance that clogs your arteries, causes heart attacks, and must be suppressed at all costs. But the functional medicine perspective presented here fiercely defends cholesterol.
They categorize it unequivocally as a vital construction material.
This is a massive paradigm shift away from the classic lipid hypothesis.
Right. The argument here is that cholesterol is not a bodily toxin. It is an absolute biological necessity.
Okay, how so?
Well, it provides the structural integrity for the phospholipid bilayer of every single cell membrane in your body.
Every single cell.
Yes. And it is the foundational precursor molecule for all of your steroid hormones, testosterone, estrogen, cortisol.
Whoa.
And your brain is roughly 60% fat and highly dependent on cholesterol for the formation of myelin sheaths, which insulate your neurons.
They even point out the synthesis of vitamin D, right? When sunlight hits your skin, the UVB radiation interacts with a specific form of cholesterol in your skin to manufacture vitamin D3.
Which acts more like a master hormone regulating immune function than a simple vitamin.
Right. So if you chemically crush your cholesterol levels, you are literally crippling your body's ability to utilize sunlight.
The crucial distinction the platform makes is that the real enemy isn't the presence of cholesterol, but rather the oxidation of cholesterol. Specifically, the oxidation of ApoB containing lipoproteins.
Let's break that down because this is where the conventional view misses the nuance completely. It's not about the total number of bricks at the construction site, it's about the condition of the bricks.
Exactly. When LDL cholesterol particles are exposed to high levels of oxidative stress, driven by chronic inflammation, environmental toxins, or persistently high blood glucose levels, The lipids and proteins within that particle become physically damaged.
They oxidize.
Yes, they oxidize. And it is only this damaged, oxidized LDL that the immune system recognizes as a threat.
Oh, interesting.
Yeah, macrophages, which are immune scavenger cells, they engulf this oxidized cholesterol. They transform into foam cells, and they embed themselves in the endothelial lining of your arteries.
And that is the genesis of atherosclerotic plaque.
Right there.
So the plaque isn't caused by just having cholesterol floating by. It's an inflammatory immune response to damaged cholesterol. Now, because of this mechanistic view, the source material is highly critical of statins, which are the most commonly prescribed drugs used to artificially block the liver's production of cholesterol.
Yes, they are very critical.
Yeah, we have to be incredibly clear here for everyone listening. We are exploring a specific biological philosophy. We are impartially reporting the arguments presented. Please do not go throw away your prescribed heart medication without consulting your cardiologist.
Absolutely consult your doctor.
Yeah.
The rationale being presented here, however, is that statins work by inhibiting an enzyme called HMG-CoA reductase in the liver.
Okay.
By blocking this enzyme, you effectively shut down the assembly line, dropping total cholesterol numbers and providing the desired blood test result.
Which looks great on paper.
Right. But from this perspective, you are starving the body of its most critical repair material.
They actually reference a podcast with Dr. Asim Malhotra, right? He's a highly credentialed UK cardiologist who has published peer-reviewed papers in the British Medical Journal questioning the widespread prescription of statins for primary prevention.
Yes, and the concern highlighted there is that starving the brain of this essential fat could be linked to the early onset of cognitive decline and mitochondrial dysfunction.
The mitochondrial aspect is key, right?
Totally. That same HMG-CoA reductase enzyme that produces cholesterol is also responsible for synthesizing coenzyme Q10.
Which does what?
It's a vital molecule for mitochondrial energy production. This is exactly why a common side effect of statins is profound muscle aching and fatigue. You are literally inhibiting the energy production of your cells.
Wow. So the philosophy here is clear. Do not chemically restrict the body's raw materials. Instead, do the hard work of removing the oxidative stress that is damaging those materials in the first place.
Stop blaming the firemen for the fire just because they're always at the scene.
I love that. And this intense focus on the quality and bioavailability of raw materials naturally flows into their rapid-fire advice on protein.
Right.
A user asked for high-protein replacements for eggs due to a severe allergy. And the answer really highlights the difference between just reading a nutrition label and actually understanding cellular biology.
Because most people view protein strictly through the lens of macronutrients. If a protein bar says 20 grams, they assume their muscles receive 20 grams.
Right.
But the platform immediately pivots the conversation to net nitrogen utilization and bioavailability, recommending a supplement called Perfect Aminos.
Why amino acids instead of just a different protein powder like whey or pea protein?
Well, because amino acids are the actual isolated building blocks. When you consume a complex dietary protein like a steak or an egg, your body must expend a massive amount of digestive energy utilizing hydrochloric acid and proteolytic enzymes to cleave those complex protein chains down into individual amino acids.
Right before they can cross the intestinal wall into the bloodstream.
Exactly. And it's not a perfectly efficient process.
It's not at all.
During that cleaving process, a significant portion of the protein is catabolized. It is burned for energy or converted into nitrogenous waste like ammonia and urea, which your kidneys then have to filter out.
But the essential amino acid blend they recommend is formulated in the exact specific ratio the human body requires for protein synthesis.
Yes, because it is pre-cleaved and perfectly balanced, they claim it is 99% utilized by the body for building tissue with virtually zero nitrogen waste.
So it requires zero digestive effort.
Zero.
So even though it's physically a tiny scoop of powder with negligible calories, it provides the biological tissue-building equivalent of 30 grams of dietary protein because the bioavailability is mathematically perfect.
It is pure, instantly usable cellular mortar.
That's amazing. They also offer excellent whole food alternatives that prioritize the same efficiency, though, right?
Yes, they highlight shelled hemp seeds, noting an impressive macronutrient profile. For every 1 gram of carbohydrate, you get 10 grams of highly bioavailable plant protein.
Plus, hemp seeds are loaded with heart-healthy omega-3 fatty acids, which directly counteract the oxidative stress we were just discussing regarding cholesterol.
They also list grass-fed beef, pasture-raised chicken, and wild-caught fish. Sure. Emphasizing the sourcing to avoid the inflammatory omega-6 profiles found in factory-farmed animals.
And then they drop some hidden, highly bioavailable sources like cottage cheese and raw A2 full-fat yogurts.
The A2 distinction is important there because it refers to a specific type of casein protein that is much less inflammatory and easier to digest than the A1 casein found in most commercial dairy.
The overarching trend is unmistakable. High quality, uncorrupted, perfectly bioavailable raw materials.
Yep.
And providing those pristine materials is absolutely paramount when we graduate from building basic tissue to synthesizing the most complex chemical messengers in the human body, hormones.
Oh, well, this brings us to a really nuanced part of the Q&A regarding naturally raising testosterone levels using peptides.
Now, the source is emphatically clear here. Do not try to biohack your endocrine system in your garage.
Please don't.
Hormonal feedback loops are incredibly sensitive, and you need a functional medicine practitioner or a regenerative medicine physician.
Definitely.
But they dive deep into the mechanisms specifically contrasting peptides with traditional exogenous hormone replacement. So what exactly is a peptide doing differently?
A peptide is a short chain of amino acids, but it functions differently than the structural amino acids we just talked about.
Oh,
Think of a peptide as a highly specific line of biological code, a targeted signaling molecule.
okay.
When you introduce traditional exogenous TRT, like injecting synthetic testosterone into the muscle, you are overriding the system.
Right.
Your hypothalamus senses the massive influx of testosterone, assumes the testes are overproducing, and completely shuts down the natural signaling cascade. Your natural production drops to zero.
So you outsource the job so the factory just shuts down.
Exactly. But the peptide they discuss, gonadorolin, works fundamentally differently. Gonadorolin acts upstream. It mimics the natural pulsatile release of GnRH from the hypothalamus. It signals the anterior pituitary gland to release luteinizing hormone and follicle-stimulating hormone.
Oh, I see. So it essentially knocks on the door of the testes and says, hey, the brain is officially requesting you to manufacture more endogenous testosterone.
Right. You aren't replacing the system. You are chemically coaxing the body's natural machinery to upregulate its own production.
That's so much harder.
They also mention non-peptide interventions like the adaptogenic herb Tongkat Ali, which research suggests can lower sex hormone-binding globulin, or SHBG, thereby freeing up bound testosterone in the blood so it becomes active and usable.
But here's the most crucial foundational point they make about the entire hormonal system. None of these signaling tricks matter if you are deficient in the foundational raw materials.
Yes, you have to get a full-blown comprehensive hormone panel done, because you might be furiously signaling the factory to build testosterone, but if you are fundamentally deficient in DHEA, it's biologically impossible.
Okay, remind us what DHEA is.
DHEA, or dehydroepiandrosterone, is a prohormone produced by the adrenal glands. It is one of the primary foundational molecules that the body enzymatically converts into both testosterone and estrogen.
Ah, okay. So if we go back to the construction site analogy, gonadorolin is the foreman yelling through a megaphone for the workers to build a wall.
Right.
But DHEA is the delivery truck carrying the actual bricks. If the truck never arrives, the foreman can yell all day, but no testosterone is ever going to be synthesized.
It is such a flawlessly logical way to look at human physiology.
It really is.
Yeah.
And this logic is applied with incredible precision to the final and perhaps most emotionally taxing question in the source material, postpartum health.
Yeah, this one is heavy.
A new mother asked about dealing with severe postpartum brain fog hyperhidrosis, which is massive excessive sweating and intense debilitating mood shifts.
The hormonal and metabolic crash following childbirth is arguably the most violent physiological shift a human body can survive.
Pretty massive.
For 9 months, the placenta has been acting as a massive endocrine organ, pumping out astronomical levels of progesterone and estrogen. Within minutes of birth, the placenta is gone. The hormone levels plummet off a cliff.
The body has to desperately try to reboot its own dormant endocrine system while simultaneously recovering from massive physical trauma producing breast milk and enduring chronic sleep deprivation.
It is a total systemic shock.
So what is the functional medicine approach to this? Because they don't just offer platitudes like, sleep when the baby sleeps.
Well, they immediately target a highly specific, genetically driven metabolic bottleneck. They instruct her to immediately stop eating any fortified or enriched foods that contain synthetic folic acid.
This is a masterclass in understanding root cause mechanics. Folic acid is the completely synthetic lab-created version of vitamin B9.
Right.
It was mandated by the government to be sprayed onto commercial wheat cereals and grains decades ago to prevent neural tube defects in developing fetuses.
And while well-intentioned, the problem is that human cells cannot use synthetic folic acid. It must undergo a complex enzymatic conversion process in the liver to become the biologically active form methylfolate.
And this conversion relies on an enzyme produced by the MTHFR gene.
Exactly. The MTHFR, or methylenitric hydrofolate reductase gene.
What a name!
I know. The massive variable here is that an estimated 30 to 40% of the population has a genetic polymorphism, a mutation in this exact gene.
40%, that's huge.
It's huge. Their bodies produce a defective enzyme that struggles to convert synthetic folic acid into usable methylfolate.
So what happens when a mother with this mutation eats fortified cereal or takes a cheap standard prenatal vitamin loaded with synthetic folic acid?
The synthetic folic acid enters the bloodstream but cannot be converted. It literally piles up in the blood. Even worse, it has a high affinity for folate receptors on the cells. It acts as a competitive inhibitor. The useless synthetic molecule binds to the receptor, blocking the cell from absorbing whatever real natural folate the mother might be getting from eating dark leafy greens.
She is essentially starving her cells of a critical nutrient while swimming in a sea of its synthetic imposter.
Exactly.
But how does this specifically cause brain fog and mood shifts?
Because methylfolate is an absolute prerequisite for the folate cycle, which drives the methylation cycle, which is ultimately required to produce a compound called BH4, or tetrahydrobiopterin.
Or BH4.
BH4 is the critical rate-limiting cofactor required to synthesize massive neurotransmitters. Without BH4, you cannot convert tryptophan into serotonin, and you cannot convert tyrosine into dopamine.
Wow, let me synthesize that because that is a profound mechanical chain reaction.
Yep.
The mother's brain is physically incapable of manufacturing serotonin, the chemical that makes us feel stable and happy, and dopamine, the chemical for focus and drive, because the cellular receptor is jammed with the synthetic vitamins sprayed on cheap bread.
Yes, it's not a character flaw. It's not just new mom exhaustion. It is a literal chemical blockade preventing the synthesis of joy and clarity.
The brain is trying to build a complex neurochemical house with fake plastic bricks.
That is why the platform's advice is so precise. Stop the synthetic intake immediately and switch to a methylated prenatal multivitamin.
Methylated meaning the vitamins have already been converted in the laboratory?
Yes, they have the methyl group attached. When the mother takes L-methylfolate, it completely bypasses the broken MTHFR genetic bottleneck. It crosses the blood-brain barrier, instantly kickstarting the synthesis of BH4, serotonin, and dopamine.
The lights in the brain suddenly turn back on.
Exactly.
And this brings us to their ultimate foundational piece of advice. Test your genetics. Don't guess what your body is struggling to process.
A simple cheek swab can reveal your specific metabolic blueprints. If you know exactly which enzymatic pathways are inefficient, whether it's MTHFR for neurotransmitters or GSTM1 for glutathione and Lyme detox, you can simply supplement the exact missing bioavailable materials.
You stop fighting your biology and start giving it exactly what the blueprint demands.
Exactly.
Wow. We have covered a massive amount of incredibly dense biological ground today.
We really have.
We started by completely reversing our understanding of digestion, realizing that the painful burn of reflux is actually a mechanical failure caused by a lack of acidic signaling.
And exploring the catastrophic ecosystem destroying collateral damage of bowel flushes.
Right. We detailed the meticulous symbiotic rebuilding of the gut using prebiotics, colostrum, and binders. We went to war against invisible environmental invaders, detailing the saturation of liver pathways and the extreme hormetic power of transdermal ozone to combat mold toxicity.
We looked at chronic Lyme disease not just as a simple infection, but as a total hijacking of the immune system's processing power, allowing dormant background viruses to crash the system.
And finally, we redefined our metabolic architecture. We defended cholesterol as vital, vulnerable cellular mortar, prioritized perfectly bioavailable amino acids, and understood that whether we are coaxing the pituitary to build testosterone or rescuing a postpartum brain from neurotransmitter depletion, the body simply cannot function without its genetically appropriate raw materials.
If we connect all of these seemingly disconnected threads into the bigger picture, the profound takeaway from this functional framework is a complete radical reevaluation of what a symptom actually is.
Yeah.
Modern, fast-paced pharmaceutical medicine often treats symptoms as errors, random mistakes made by a flawed biological machine that need to be silenced, suppressed, or chemically overridden.
Right.
But the evidence explored in this deep dive suggests the exact opposite. The symptom, whether it is the lax cardiac sphincter allowing acid to splash the systemic inflammation of an overtaxed liver, the dormant shingles virus waking up, or the crippling postpartum brain fog, is the body acting perfectly flawless logically.
It is functioning exactly as it evolved to function in response to a flawed environment, a lack of bioavailable building blocks, or a completely overwhelmed immune system.
The body is never making a mistake. It is constantly adapting to survive the exact conditions you are providing it.
That is profound.
Yet,
It genuinely makes you rethink every ache, every pain, every moment of fatigue. And so I want to leave you with a final thought to mull over as you go about your day. Think back to that check engine light we talked about at the very beginning of the show.
yeah, the dashboard.
If the biological mechanisms we explored today are right, and things like chronic acid reflux, the lingering exhaustion of Lyme, or the heavy cloud of brain fog are just the body's warning lights flashing wildly, what other diseases or conditions in our modern lives are actually just environmental mismatches we've arrogantly mislabeled? Are we spending our whole lives desperately trying to smash the fire alarm with a hammer instead of just giving the body the water it needs to put out the fire?
It's a great question.
Thank you so much for joining us on this deep dive. Stay curious, listen closely to your body's alarms, and we'll see you next time.